Okay, we're live on YouTube. And here's the question we want to ask for the next few minutes. Why are noble gases so stable? Well, if you look at your periodic table, if you look at your Bohr diagram, where is my periodic table? Why?
Yeah, they have no charge.
Sadie had an epiphany. Sadie, can you say that loud and proud, please? Why are the noble gases so stable?
Because they all have no charge.
And then we need to ask, why do they have no charge? Because they have a full valence shell. Their outer electron shell is full. And what we're going to say is atoms want a full valence shell. Now, I'm fibbing a bit because atoms aren't alive. They don't want anything. But the universe seems to be happiest when atoms have a full valence shell. So atoms want to try and become their closest noble gas. Okay? So what's different about the noble gases? They exactly match the 2-8-8-18 rule. Helium has 2 in its outer shell. Neon has 8 electrons in its outer shell. Argon has 8 electrons in its outer shell. Krypton has 18, etc. So, noble gases have full valence shells. So they can't lose or gain electrons. That also means they don't conduct electricity, so they're sometimes used in really expensive applications as insulators, expensive insulators. Okay? All other atoms want, and I put want in air quotes because atoms are dead, they don't want anything, Kalen, but what I really mean is the universal laws dictate that atoms want a full valence shell, and they want to lose or gain electrons to do it. So look at chlorine. I'm going to zoom in. And you can find it on your periodic table. I got to go over a little further. Chlorine is element number what? 17? I got to scroll up, Mr. Dewick. 17. Come on, work with me. Right here. So here's element number 17. Bit bigger. How many electrons? What's the easiest way for chlorine to get a full valence shell? Well, one way would be to lose all the electrons going that way, but that's a lot of work. The easiest way for chlorine to get a full valence shell is just to gain one more electron and become just like argon. Non-metals want to gain electrons. They're going to grab electrons from metals and hold on to them. So, what about calcium? Well, calcium, for it to get a full valence shell, it could either gain 16 electrons or it could lose 2 electrons. Way easier to lose 2 electrons. Metals will lose electrons. So metals are going to get rid of electrons in their outer shell. Non-metals are going to try and fill up their outer shell. Metals are actually going to try and get rid of their whole valence shell. Okay? What do you notice about the number of electrons lost or gained in the ion charge? The number in the upper right corner. So this number right here, let's look at sulfur. That 2 minus, the 2 says it's going to gain or lose 2 electrons. The minus says, since electrons are negative, it's going to gain 2. Or if you look at magnesium, that 2 plus says it's going to gain or lose 2 electrons. The plus means, since electrons are negative, it's going to lose 2. You're going to notice some weird ones where there's atoms that have more than 1 ion charge. We'll talk about that a bit later. Okay. So, an atom that has gained or lost electrons has a charge. And it's called an, and this is the word that I didn't explain before that I should have because it was on your sheet. Starts with letter I. Yes. An ion. And the charge that forms is shown in the upper right corner of your periodic table. If there's no number, like potassium, can you all see potassium, element number 19? There's just a plus. What number is technically in front of that? Yeah, it's a 1. Okay? So potassium wants to lose 1 electron. That's why it's so reactive. Yes?
What about manganese, number 20?
So in the middle, because the electron shells start to overlap, it turns out those are stable with several different types of ion charges, and so they're actually willing to be stable even though their valence shell hasn't quite been filled, and it's because they're actually sharing electrons from lower shells. It's a complicated thing, but it just is what it is. We call them multivalent, by the way. Okay? To show that something has become an ion, you draw the Bohr diagram with the little circles. You add or subtract the electrons as necessary. And then to show that it's an ion, we put square brackets. And then we indicate the charge outside the brackets. Put your pencils down once you've written that down and look up. Okay. Aiden, if you can do me a favor, if you can pick an element from the second row of the periodic table, but don't pick neon because it's boring.
Where, what does that say? Sorry.
Oh, square brackets and charge. So Aiden, pick element either 4, 5, 6, 7, 8, or 9. Fluorine, okay? Look up. I'm going to draw a fluorine ion. First thing I would do is I would draw a nucleus. Aiden, what's fluorine's everybody find fluorine on your periodic table? What's its atomic number? Or is that a 9? How many protons? 9 protons. What's its atomic mass? 19 take away 9 is 10 neutrons. What row, how many rows down is it? So the first shell is going to be full, 2. Don't write this down, just watch. You're going to do this in your homework, but I'll do one where you can kind of watch all the steps. The second shell, if it was an atom, I would just count, and I think the second shell, normally it has 1, 2, 3, 4, 5, 6, 7. But now it's an ion. Is it going to lose all 7 electrons to get a full shell? Or what's the easiest way for it to get a full shell? Instead of losing 7 electrons, it can add 3? Add 1. So I'll do it in a different color just to pretend that it came from a different atom. You don't need to, but that's the extra electron. And then to show that I did that deliberately, that it's an ion, I put square brackets around it, and I put the ion charge, which is from the top left on the periodic table. That's how you draw a Bohr diagram of an ion. Square brackets to show that you didn't make a mistake, that you have the wrong number of electrons from the periodic table on purpose. You know what you're doing. and then the charge to also say, hey, I know how this works. Okay? Pick your pencils up, back to your notes. Chemistry humor? Nothing. Okay. So this says, draw a Bohr diagram for an atom of sulfur. I can't remember if I gave you the circles on your sheet or if I just gave you some blank space. I think in your notes I just gave you some blank space. Is that so? We're going to freehand this. Yep.
Do we have to put square bracket?
Yep, for an ion. Yes. So let's do sulfur. First question. What's sulfur's atomic number? So somewhere I'll just make a little note, 16. Here we go. There's the nucleus. What's its atomic number? 16. How many protons? Same answer. So inside the nucleus, I'll write 16p plus. What's sulfur's mass? 32. So 32 take away 16 is conveniently same number of neutrons. What row is sulfur on? How many rows down is it from?
3.
I'm going to ask you the same question. I'm just going to phrase it differently. How many shells will sulfur have normally? 3. Is it a metal or a non-metal? Sulfur, non-metal. It's going to gain electrons and fill its shell. So here's the first one. First shell. How many electrons in the first shell? How can I remember? I can memorize the 2, 8, 8, 18 rule, or you can just count across the first row. Hydrogen, helium, 2. Here's the second shell. Also, you'll notice I'm not going to be too fussy, Nick, if you're drawing these messy. As long as it's clear where the electrons are, you can see I can't draw a circle to save my life. I'm not going to be freaky about that. And if you want to use a compass and be really neat, go ahead. I'm not going to bother. How many electrons in the second shell? Well, since it's in the third row, its second shell must be full. 1, 2, 3, 4, pair 5, pair 6, pair 7, pair 8. How many electrons in the third shell? Well, if we were drawing a Bohr model of the atom, it would be 1, 2, 3, 4, 5, 6, 7. I would just count over from the left. I would just go 1, 2, 3, 4, 5. Sorry, 7, 6, Mr. Dewick, not 7, 6. Can't count. There we go. Can you find sulfur on your periodic table? What's its ion charge in the top right corner? 2, and negative because it's gaining. So I'll change colors just so you can kind of see. I'm pretending that this electron came from a metal somewhere and this electron came from a metal somewhere. Raphael, do I have to do the square brackets?
No.
Yes. Square bracket to show that it's an ion, and then 2 negative to show the ion charge. I'm teaching you how to do Bohr diagrams, Casey. I've already decided, because I hate Bohr diagrams, I'm not going to put Bohr diagrams on your test. It's going to be Lewis diagrams, which are way simpler, and you'll see why we like them so much more. That's Monday. So, nonmetals form negative ions because they gain electrons. Metals form positive ions. And as Casey noticed, in the middle section especially, some metals can form an ion in more than one way. I wrote here, draw a Bohr diagram of an aluminum atom and an aluminum ion below. Let's do a little divide your page kind of in the middle. Aluminum, what number on your periodic table? 13. Now, by the way, I'm going to promise you right now, I'm not going to have you draw a Bohr diagram of element 76 or something stupid like that, where there's 7 or 8 electron shells, Nick. I'm going to stick basically in the top 3 rows and a little bit into the 4th row. It's just too much drawing. So aluminum number 13. Okay, here we go. There's the nucleus. 13 protons. How many neutrons in aluminum? Is it 14? 27 take away 13? 14 and 0. I know you can't see it at the back, but I got to write small.
So what is it?
13 P plus, 14 N zeros. What row down is aluminum? 3rd? So, first shell is going to be full with 2. Second shell is going to be full with 1, 2, 3, 4, 5, 6, 7, 8. And for an atom, how many electrons will it have in its 3rd shell? Count over from the left. Aluminum, where's aluminum? 1, 2, 3. I agree. So in my 3rd shell, one, 2, 3. That's an aluminum atom. An aluminum ion, Kalen, look up, is going to look like that, but with square brackets. I'll bring that back because I can, but that whole outer shell will vanish. So let's draw that. And thankfully, the ion's a little easier to draw. It's still going to be 13 protons. It's still going to be 14 neutrons. If you get a picture and you can't fit numbers in the nucleus because the picture is just so small, you can also write the number of protons and neutrons underneath everything, 13P plus, 14N0. I'm not fussy. Inner shell. Middle shell. Going to have 8. Is it an ion? Everybody say yes.
Yes.
So is there going to be an outer shell? It's going to have lost its outer shell. It's going to have given those electrons away to a nonmetal. How do I show it's an ion? What do I have to put around it? Square brackets. And the ion charge, which is 3 plus. So, I mean, the Bohr diagrams, they're useful. There's a lot of information. They're just a pain because they take a lot of time to draw. Not a huge fan of them, really. So, valence electrons.
It is almost 1040.
It is 1140, actually.
Oh, I thought that was 1040.
And so, I'm going to pause here. Okay? Your homework that you want, if you're trying to keep up with stuff so that you don't suddenly want to be overwhelmed with homework, I would say to you, I'm going to give you more time to work on this section 2.3 homework that I screwed up on. But you want to have, by Monday, section 2.2 homework done. You want to have section 2.1 homework done. Those of you that did not attend class yesterday, now I'm going to pause the video.